You're stunned from the previous session? Good afternoon, everybody. Yeah, much better. How about when in doubt? All right. We'll work more on that. Welcome to the Case of the Unexplained. My name is Mark Russinovich, and this session today I'll be showing you tools and techniques for troubleshooting problems that you might run into on Windows systems, including, as you can see, broken down by symptoms here, various categories that I'll focus on, with examples of each one of these, including sluggish performance, how to figure out what's behind a cryptic error message, application crashes, and then finally I'll conclude with a look at blue screen of death. How many people have seen a Case of the Unexplained before? Looks like about a third of the audience. Welcome back. This session is all brand new in terms of the demos and cases inside of it, although a lot of the techniques and tools obviously are going to be shared from previous sessions. But if you like this session, I recommend you go back and look at previous sessions and read my blog where I've got a whole bunch more cases. If you go to Sysinternals.com and scroll down to the right, the left rail here, you can see Mark's webcasts. And you can see I've got 5 previous Case of the Unexplained. They've all got totally different demos and sometimes different tools in them even. And then if you go to Mark's blog, you'll see a whole bunch of cases. Like one of them that I'm going to be covering here is documented in the blog. Here's very slow logons. Case of my mom's broken Security Essentials installation. There's another one. Yes, my mom gets infected with malware too, just like yours. And so you can find other examples like that on that site. These are all based on real case studies, so none of these are fictitious. They're either ones that I've run into myself or that people have sent in to me. And if you solve a case with the Sysinternals tools, I ask you that you document the case, capture screenshots, get the log files, and send them to me so I can put them in the library. It's kind of stunning how big my library of cases has gotten. I don't know what kind of a statement this is on Windows, but I've got now 9 PowerPoint decks, and that might, 9 PowerPoint decks. Well, they're each 200 slides long of cases. And so when I come up with a new Case of the Unexplained, I just go, oh, let me go back and pick some cases that show some interesting things, and voila, I've got a new Case of the Unexplained. The reason that we even have to have a session like this is that applications generally do a pretty poor job of reporting problems. The fact of the matter is that developers spend their time on the regular paths, the kinds that they test in their dev labs, their build labs, their test environments, in their betas, where the applications are accessing the registry keys they expect to access, finding the files they expect to access, and generally performing well. What happens in the real world, though, when it gets out onto lots of end-user machines, and especially ones in corporations where you've got IT pros that feel like they need to go mess with things to
in Visual Studio 2013
justify their jobs, is that you'll run into applications that can't access their files because of a permissions problem, that load the wrong DLL because of a path problem, that crash because a registry value has become corrupted by a different application. And when that happens, the code falls down into a path that the developer never even bothered thinking about or testing. They call a function that returns an error. They don't check for the error. Then they proceed as if that's going to work, if that was successful. And they call another function with a bogus buffer, and that causes a crash or an exception, and then they throw up some dialog based on the second function, not what the first function returning an error. And so you get the bizarro error message. My favorite one is unknown error. That's incredibly helpful. And I don't know, it's not okay. I don't know why they ask you to press OK on those things. So that's what we're here to talk about, is how you can look behind, under the covers, to find out what's going on when you run into that. There's no, formula for troubleshooting. The fact of the matter is, troubleshooting is as much art as it is science. The science is the tools and some of the techniques. The art is applying them and being a detective. In many cases, you solve just by getting some clues and having ahas, like maybe that's related to that. And it's not something flashing a big red light saying, here's the problem right here. You're going to learn by experimentation and practice. A lot of troubleshooting means understanding the way that the system works under normal conditions. So when you see a process in the process list, you say, oh, I know that that's a legitimate process, I know what it's for, versus every time you sit down going, what is that, and spending a lot of time just getting a baseline of what's going on. The tools that we're going to use, of course, are the Sysinternals tools. I think they're probably the best tools, if I say so myself, for troubleshooting. There's about 70 of them on the site. Here's a subset of the ones that I've used in this case of Unexplained as well as previous ones. Of course, the big three heavy hitters are Autoruns, Process Explorer, and Process Monitor, so you will see all three of those, and you will see some other tools along the way. There's also another tool, not written by me, but it's still pretty good. It's called the Windows Debugging Tool, Windows Debugging Tools Debugger, and I'll show you that tool in the context of crash debugging. And before I get started, one last thing, it's a little mini commercial. If you want to really dive deeper even than just looking at blog posts and playing with the tools, this book, co-authored by me and Aaron Margosis, Aaron's somewhere in the room. Aaron did the bulk of the writing, and he actually convinced me to put his name on the front cover, so I eventually did that. But did a great job of documenting the way that the tools work in their full entirety. So if you really want in-depth exactly what to do with lots of examples, this is the book. And Aaron is going to be in the same room right after this doing a Sysinternals primer that is going to go deep on several of the tools specifically rather than a troubleshooting focus. It'll be a tool-focused talk. Finally, one last thing about the book signing I did. There was a lot of people that bought books that I didn't get a chance to sign then. I will be signing books that you've got between the sessions and even after the Sysinternal sessions if I didn't get a chance to get to you. And thanks for purchasing. All right, let's get started now on the heart of the presentation, which is troubleshooting. And we'll start with sluggish performance. How many people have had sluggish performance on Windows? No, I'm just kidding. So this case was a case where Explorer was very slow to display the contents of local folders. That should say local folders, not local files. Now, the first rule or the first question, kind of whenever you approach a troubleshooting situation, is to ask the number one question when it comes to sluggish performance, and that is, are you running Windows Vista? No, I'm just kidding. No, there's a lot. Vista has come a long way, and there's people that like Vista, and so we should respect their opinions. They're valid, just like everybody else's is. So what this person did was capture a trace with Process Monitor. Let's talk about Process Monitor here. It's a real-time file system, registry, and network thread monitoring tool. How many people have run Process Monitor? Almost all of you have run Process Monitor. Good to see. Here's the expression that Dave Solomon actually came up with based on the fact that 90% of the cases that I get from people and that I solve myself are solved with this tool. And it's become so reliable at solving problems that you wouldn't even imagine it's able to solve that Dave came up with the slogan, when in doubt, run Process Monitor. So if you hadn't been at the previous session, that's what I was asking people to say. So let's all say that together. Okay? 1, 2, 3. When in doubt, run Process Monitor. That's getting better, and we'll still have more practice later on. So it's going to often show you the cause for error message, and will ironically show you the root cause for sluggish performance. You might think, oh, that's Process Explorer for sluggish performance. But Process Monitor is the tool. Let's pull it up, and for those of you that haven't seen it, I'll just give you a quick tour of its user interface. And it starts up. Where'd you go? There we go. It starts up just automatically monitoring everything that's going on in the system. And there's a lot of just background activity. You can see I'm already up to 70,000, or actually 350,000 events. And by the way, I'm using a tool to do this zooming called Zoom It. And Zoom It is a tool that will let you do things like draw on the screen, like this, and like that, different colors. And when I'm on the airplane by myself, I just scribble like this until the person next to me wonders what I'm doing. But it's a lot of, and then I give it to my daughter for her birthday as a drawing tool for her to do little projects with, and she really likes it. Or she's afraid to tell me that she doesn't, I don't know. But so Process Monitor is, well, what it'll show you is a few columns of information. The first column is the process that's performing the operation, the process ID, the actual operation. You can see that here a service host is enumerating values in the registry, the environment variable, environment registry value to be precise, and reading different environment variables out of that. So we can assume that that's where environment variables are stored, at least the global ones. Here we can see Explorer reading a registry key. Here we can see Explorer querying the size of a file. And what Process Explorer will show you, or Process Monitor will show you in the far right in the detail column, is data that comes back from that operation. So you can see exactly the size of this file, which was actually a directory, Windows Explorer, that it's a directory that has, well, it's actually querying the size of the volume. So this is what comes back as the size of the volume. You can see how much space has been allocated and is free on the volume. So lots of detailed information there. One of the features that I've recently added, and I'm going to show you some more of the features of Process Monitor, but here's one that I've added, which lets you set bookmarks inside of a trace. And you can do that by just saying Control B. You'll see me use a bookmark in a case a little bit later. But once you've got bookmarks in a trace, and the reason you'd want to put them in a trace is so that you can go back and reminisce fondly about how you solved the case. You can just say, oh, what did I do? Oh, I F6. Oh, that's right. I figured it out by seeing this link right here. And so that's what I spend a lot of my time doing, is going back and finding my bookmarks and reminiscing about my success stories. And you can also show other people how successful you are. This will be saved actually in the file. So the real purpose is troubleshoot a case, find something interesting, send it to somebody else, and then say, you know, go find the bookmark. That's where the interesting stuff is happening, and they can figure out what's going on. Let's get back to this case of a sluggish Explorer. And actually, I have a kind of a repro of this case here locally. This command prompt is acting pretty funny. Watch what happens when I launch Notepad. That took a little bit longer than it should have. Actually, it went a little faster that time. But that took longer than normal, and we're going to find out why it took longer than normal using Process Monitor. I'm going to use this bullseye here to drop it on the process that was exhibiting the problem. And this is one way to set a filter in Process Monitor very easily. I just want to see what that command prompt did. I'm going to stop the output. And now we've got one way of filtering. There's lots of other ways of filtering in Process Monitor. Another way is to right-click on a particular entry. So let's say that we suspected that it was just create file operations. I could right-click and say include just create files. Or I could say I don't want to see anything from this, and I could say exclude that. If I want the filters back, I can say Control R, and that will bring me back to the default. Or I can open up the filter dialog, and this is a handy troubleshooting feature, especially when you're investigating and you're putting in filters and you're saying, well, maybe I want to put that filter back later, but I don't want to have to worry to go to the trouble of actually doing it, is you can disable the filters. So for example, I don't want to see the create file filter applied anymore, and now I'm back to everything without create file. What? Actually, what did I do? I didn't uncheck it. And now I've got all the operations back, and I can quickly go back and just add the create file filter again. So what do we do in this situation to troubleshoot this problem? One of the tools that Process Monitor has up here is one that's frequently used during troubleshooting, and that is to look for bizarre or unusual results over here in the result column. You'll notice over in the result column there's success, no such file, there's bad network path, and bad network path is kind of suspicious in this case, file locked with only readers. Some of these are just part of the normal day in, day out grunge of APIs saying, no, don't check here, no, don't do this, go do something else, and applications know how to deal with it on a reasonable basis. One way that you can look for unusual error conditions is to use the tools count occurrences and select the result. This will let you basically count the occurrence of any particular field that Process Monitor collects information about. You can see architecture, detail, process ID, result, and say count. And these are all the errors that are in the trace, including the number of them that occurred. All of the errors except for one of them is standard for almost any trace, and the one that is non-standard is this one, bad network path. Bad network path here came back on create files for network shares that are bogus. Now, of course, I made these network shares up, but in a real environment, what might trigger this is if you've got a system that is mounted a network share that is offline or behaving sluggishly itself, and that is going to impact the behavior of the processes that are referencing it. In this case, why is command prompt referencing it? We can take a look at the environment variables that create path launched with by taking that filter out, going to the first operation. Well, actually, the first operation is not there, but what we can do is take a look at the environment variables using Process Explorer. If we saw a process launch, you can look at the environment variables. And the reason that that is querying those is because I've put that in the path environment variable for that particular command prompt. In a real troubleshooting scenario where it would affect the whole system, you would be able to look at the launch environment variables for the process and see that in Process Monitor. Let me show you that real quickly, because I can launch another command prompt, or actually launch a command prompt here, drag the bullseye onto it. I did something wrong. Oh, I wasn't tracing, sorry. Let me try that again. I'll do a notepad. Drag the bullseye onto notepad. And when I go to find notepad, and here's the way that I go find notepad, is use a feature called the process tree. The process tree shows us the parent-child relationship of every process that existed at any point during the execution of the trace, not just what I've got showing in the trace. And you can see all of the processes that have run or been running now, as well as ones that have exited. Here's the notepad. And Process Explorer lets you do a few things right from here. I can go to that event, and that'll take me to that first event in the trace. And is the environment variables that process started with. So that would be what you would see in a legitimate scenario. But I've just concocted one to demonstrate Process Monitor, some of Process Monitor's features. Let's go back to this real case of the sluggish Explorer and look at what this particular user did. This particular user sent me the log file, and this is what it looked like. This is a kind of one of those amazing log files where I'm not sure I would have been able to solve the case using this, because if I do a count occurrences for the results, I don't see anything stand out. I don't see the bad network paths. All of these are standard errors that you're going to see in any trace. So they did the same thing, and they also saw that there was nothing that jumped out there, and they went through meticulously looking at the trace for anything that could give them a clue. I set a bookmark to take us right there so I don't have to wade through it. I thought I did. There it is. And this is a particular example of what was causing this slowdown. Explorer is doing a create file of this path right here, nwfs01, and it's looking for a file called shell32, and its name not found. If you set a filter for this, you'll see that there's lots of them in the trace. What Explorer is doing is, for some reason, querying that directory, even though the folders that the user was looking at aren't anywhere on that network share. Question was why? And all it took was this clue for the systems administrator to figure out what happened. Said, well, why would Explorer for this user be querying that? I bet they've got something mapped that mapped as their home directory. Sure enough, they went and looked at the configuration for that user, and they've got their home directory mapped to that network share. And that network share was a network share that had been that was acting very sluggishly. It was on a DFS highly overloaded set of servers, and lots of people are hitting it because it's on their home directory, so lots of people were having the sluggish behavior. Confirmed by looking at Process Explorer, which I'll come back to in a second, that the current directory for Process Explorer was set to that directory there, Z, which is where that mapping was, Z. And that was the solution. So what they did was simply killed Explorer, restarted from a local directory to confirm that that was actually the problem. They contacted IT, had them change the home directories for their users, and the problem was solved. It's case solved with Process Monitor. Again, when in doubt, run Process Monitor. Okay. This next case I'm going to show you involves the use of Process Explorer. Process Explorer is a task manager type replacement. How many people have run Task Manager? Okay, that's what I figured. How many people have run Process Explorer? That's what I figured. That's pretty good. Now, Process Explorer is like a task manager that shows you a lot more information. Just to get an idea, I just did that show Task Manager. That's the way that Windows was intended to behave, right? Is you launch Task Manager and you get Process Explorer. But what Process Explorer shows you, you can see it looks very different, although the most recent Task Manager is a lot more colorful now, so it's starting to look like Process Explorer. But it shows you this process tree that Task Manager doesn't, which is the parent-child relationship between processes. I'll focus on one particular part of the tree down here, which is the win-logon tree, or win-init tree, which kicks off the whole boot process here. And it starts off services, it starts off LSAS. And then win-logon is the interactive logon manager, which launched Explorer, which launched a whole bunch of things that I'm running right now, including Process Monitor. The other difference between this and Task Manager are the difference in colors. There's blue for, I told you last session, boy processes. No, it's actually the processes that are running in the same account as Process Explorer. It means I logged in, I launched Process Explorer, so all the other processes I also launched in this login session are also blue because they're running as me. The pink processes that I've collapsed up here are ones hosting Windows services, which is why they all disappeared when I collapsed services.exe, because services.exe is the service control manager. So these are all running those daemon background jobs. Some of them are DLLs even just loaded into host processes, where others are standalone processes, and they all show up in this pink color. I added a few features. I actually added GPU monitoring for Windows 8. I've also added process timelines. I've also added auto start locations. I'm not going to be focusing on those right now, but just wanted to make you aware of them. And then I've also added heat maps. The heat maps will show us when there's processes that are consuming lots of a particular resource. And you can see that there's a process. This heat map is showing us in the column, and it's showing us right here that a process is burning some CPU. We also see it down here in the tray, and this will show us that that service host is the process consuming the most CPU on the system at that point in time. How many people like the heat maps? How many people just think I just made a horrible mistake? Okay, there's none of you in here? Good. Oh, one person. Okay, you're excused. No. Actually, there are people that have complained. And so the release of Process Monitor from this, or Process Explorer from this week, you can go to View, and you can say, where did I put it? Oh, Options. No, I put it in View. Oh, where it is. Show column heat maps. There. That's where I put it. And you can unselect that and get back the old view if you like the old view. I happen to like the new view. Otherwise, I wouldn't have put it in there. So let's get back to a case now of somebody that ran into a problem and solved it with Process Explorer. So the system was acting sluggish. They weren't running Vista. They opened Process Explorer and saw that a particular process, icq.exe here, was just burning the CPU up. And this is in these mini graphs that you see up here on the top. So let's talk about now the difference between a process and a thread. Because what they saw was that icq.exe was burning CPU. Now ICQ was a chat client that they used on a regular basis. And they wanted to know, is it really ICQ or is it something causing ICQ to burn the CPU? And to understand if something else might be causing ICQ to burn the CPU, you need to understand the difference between a process and a thread. And a process is basically just a container. It's a container that has an address space associated with it. It has a list of open operating system resources associated with it, files that are mapped into its address space, security context. But what actually executes code are the threads. They're units of execution that the scheduler in Windows will give the CPU. So it's really not precise to say that a process is running. Really, it's a thread inside the process is running. The question was, which thread in this ICQ process was consuming the CPU? Because maybe it wasn't ICQ.exe's thread. Maybe it was a thread from a DLL that had been loaded into ICQ that was consuming the CPU. So how do you view the threads? The list of threads are visible in the threads column. And we've got this example of a process that is burning CPU on my system. It is what's called a hosting process, meaning that multiple things live inside of it, and that's why it's called service host. It hosts multiple Windows services, and you can see the list of services that are hosted in it with this tooltip. One of these services is causing that CPU consumption. The question is, which one? So let's double click and take a look at the threads. And by default, we sort by, let me clap this up, so that's cheating. This sorts by CPU usage, and there's two threads that are consuming CPU. One of them has a very clear start address. A couple things here that we're looking at. First, the reason that we have these functions displayed so nicely is that I've configured Process Explorer's symbols, which you can do here. And this is the standard way to configure symbols, is to download the Debugging Tools for Windows package, install it, point Process Explorer at the DBG help, and then set this path right here. And this is documented in the DBG help file and online, so no need to memorize this, just configure it, and you'll get these nice function names for all of the built-in Windows and even some of the external Microsoft products when you look at stacks like this, or look at information like this, like these threads. This thread is consuming a little bit of CPU. This other thread's consuming a lot of CPU. This one has a start address in a particular DLL, servicehog.dll. That sounds like a suspicious name, and this is because it's my own DLL that I've made that will consume CPU. How do we deal with this? Well, we can suspend it right here. And now that's out of the way. But we still have this open question of what this thing is. And that's what this particular user ran into. When they went and looked at their threads, they're of the ICQ process, they saw this, Quartz DLL, which is a standard multimedia DLL built into Windows. There's two threads in Quartz that are consuming CPU. So is it Quartz or is it something else? In this case, is it this TPP Worker Thread, which is a generic start entry point for work items that other threads in this process throw at? Well, what are those work items and what DLL are they associated with? Which component are they associated with? In this case, what we need to do is take a look at the stack of the thread. Let's talk about stacks a little bit here. A stack is kind of basically a record of where the thread has been executing, so it can get back to where it went. It's like going through the path in the forest and leaving behind rocks, so when you go back, you can get back to the start. When you go off and do something, call a function. When you're done with that function, the way you know where to resume from is to pop the address that you saved on the stack to go back. And tools like Process Explorer know how to decode the stack, so you can see this chain of rocks that the thread has followed. The way that you interpret this, and here's an example, is the most recent rock is here, then this one, then this one, then this one. So this is the way the thread has basically started up here and worked its way down to this particular function. If we happen to catch it here in this function, that means this function, or one probably close to it, is responsible for consuming CPU. And what you want to do is look for the add-on DLLs, the plug-in DLLs that are probably responsible. In this example that I've got made up here of this service hog, if we look at the stack of this, service hog reveals itself right away in the stack. We caught that thread when we snapshotted its stack sitting there in the middle of Service Hog. This is that same service that had that other thread that was blatantly part of the launched in the DLL. This service is also throwing work items at the thread pool to execute these. And now we've completely diagnosed the fact that this particular service, Service Hog, and a feature of Process Explorer for services is it will show you the tags of services. This is a feature that's on Windows 7 and newer that will show you the service that the threads are associated with. So we can see all of the threads associated with their services. If one was consuming CPU, we'd know which one it is. So we've solved this particular case, and let me go ahead and suspend this guy so we get him out of the way. But this particular user, they looked at the stack and they saw this, video core.dll, and this is a third-party plugin. At this point, they'd solved this case, or at least figured out the root cause. It's not ICQ, it's not Windows, it's this third-party DLL, which appears to be some kind of codec. Now the question was, how do we get rid of this codec? How do we fix it? He opened the DLL view of Process Explorer to see, and noticed that each time he ran into the problem there were several DLLs loaded into the process. The DLL view is what you can open by saying Control D or opening the lower pane up here, and it will show you all of the files mapped into the process address space, including DLLs as well as executables as well as data files. So these ones up here are all data files you can see by their names, .dat, .db, and we're looking at Explorer. Here are the DLLs that are mapped into this address space. These are 4 DLLs, all show up packed. They're probably all third party. They don't have company names and version information except for this bottom one, which is licensed to Viscom software, demo version, Viscom software. So somehow they picked up this codec someplace when they were going around the internet. They went to the add and removes program to look to see if there was anything for Viscom there that they could uninstall. Nothing there. Dead end. So now they're stuck. How do we find out how to unload this codec that we don't want on our system that's causing this problem? And that's where we turn to a tool called Autoruns. How many people have used msconfig to go and look at startup stuff? Well, quite a few of you. msconfig, unfortunately, is not going to help you in this case, because msconfig basically shows executables that are configured to start up, not places where DLLs get registered as third-party extensions. So certainly not codecs. What Autoruns does, let's launch Autoruns. It's a tool that I've been evolving since literally 1997, and it knows about hundreds of places where there's extension points in Windows, from drivers to services to browser helper objects to IE plugins to Explorer shell extensions to codecs. And the full list is shown in this first view. Now, I've already applied a filter from the previous session, which is to hide signed Microsoft and Windows entries. Because otherwise and that's the default view, to hide Windows entries, not Microsoft entries, but Windows entries. Because most troubleshooting cases isn't caused by Windows, where there's some registered Windows component, but it's some third-party component. It could even be Microsoft component, registered to load inside of these processes. So Autoruns automatically sets that filter, and what I recommend, certainly in the case of malware hunting, is to check for digital signatures. This user turned to and by the way, let me give you a quick tour of Autoruns. These different columns show you the breakdown by different component, and I've got codecs over here. You see I have no third-party codecs, at least that have been scanned so far, and the reason the scan's taking so long is trying to query over here. What we're going to see pop out are references to paths on the Microsoft CorpNet that we're timing out on. So it's that path problem that we ran into. We see Autoruns getting hung up trying to scan files that are registered to start someplace but aren't on inaccessible network shares, causing very long timeouts. And we would be able to see those timeouts in Process Monitor the same way we did earlier. When those come back, I'll comment about them in a second. The other things you can do here, besides looking by category, is see specific information about a particular item. I select this RoboForm toolbar, for example. I see it's this DLL from Cyber Systems. It's a class, a COM class object, so it's got this class ID here, its version number, the time it was made, and the size. And I can go and jump to the entry in the registry, where this thing is registered, right as a toolbar extension. And there it is. That's that name for the toolbar extension. I can jump to the location in the file system to where this thing is located. Right there, roboform.dll. And I can also search online if I want to. Let's see if those... Here we go. So these are those pesky IT things here, which is Microsoft has put on. And I don't know why we're still using Inoculan. Update I know dist here and not Forefront. So I probably shouldn't be showing you this, because I thought we'd already switched to Forefront for everything, but maybe we haven't, or this is a stale IT script. But one of the unfortunate things is I can delete this, and the next time group policy is applied, it'll come back. At least it would come back if I hadn't fixed it, so it wouldn't. And if you want to know the secret to that, send me an email. Let's go take a look at the Autoruns file that this user collected for this case. They didn't run with a filter, so we're going to see this viscom right there. Here's a viscom DLL, and it's called the custom frame grabber filter, viscom frame. They went and found all of these viscom related files. You see the screenshot he sent me right here. Right, where'd you go? Right here. He found the same thing, and he disabled all the viscom filters, killed ICQ, started again, problem solved. No more spiking CPU. So he started with some process consuming a lot of CPU that shouldn't be, drilling in to look at the threads, still didn't have an answer, drilled in to look at the thread stacks, saw a DLL, used Autoruns to figure out how to go and disable that DLL when there was no add remove program. So a combination, I think, really cool of all three tools being used to troubleshoot this problem. Here's another case. Company taking 15 minutes to log on. How many people have run into this before? And how many people blame it on IT group policy scripts? Yeah, so this case is going to resonate then. So the logins were taken for one particular OS image across the fleet of computers were taking 5 to 15 minutes. For the rest of the computers, normal logon times. What was the difference between the two? So the reason this even came to the IT desk is the executives were on this new OS image. And so they're like, what the hell is going on with you guys? Somebody better get to the bottom of this or somebody's going to get fired. So this showed up on this admin's desk, one of the admin's desks. They tried everything. They were looking at the event viewer, didn't see anything. They captured a Wireshark trace. They didn't see anything. They checked for malware. Nothing. Finally, an admin that had been in this session said, what? Win it, run. Come on. That's it? You're still not convinced? All right, well, it's the fifth. That's the last day of TechEd. I'll give you a break. But we are going to say that really well later. I'll give you a pass this time. So they saw a case of Unexplained. The problem is that this was happening during logon. So how do you capture a trace of activity with Process Monitor that happens when the system is booting up? The answer is that Process Monitor has the capability to capture a full trace from very early during the system's boot to all the way when it shuts down. And that is with the boot monitoring capability. If I go open up here, you can see enable boot logging. Actually, I need to launch it elevated, and you will see Process Monitor here. Oh, it's already on. It's this one. So if I go to Options, Enable Boot, You can say, you can even generate profiling events. So this is captures of thread stacks at every second interval, every 100 millisecond interval, which is good for looking when you don't see any file system or registry activity over a long period of time. This will let you know what those threads are doing by looking at their stacks, because Process Monitor can look at stacks as well. What they did was enable that, and let's go take a look at the log file that they captured from that boot trace of one of these systems that was behaving in that very sluggish way. So 15-minute logons. There's lots of information here. There's 260,000 events, lots to go through. What they did was use the process tree view to look to see what kind of activity occurred during the process launch. The green bars here in the timeline represent processes that are still active at the time that Process Monitor started. What they did was say enable boot log. They rebooted the system. Process Monitor started capturing everything. After the system was logged in after that long delay, they ran Process Monitor again. It will say, hey, I've been collecting a boot log. Would you like me to save it out? They specify file, and that's what they're looking at this point and what they sent me. They went scrolling through here, and this is one of those cases where if you work at a company, you know kind of in IT, you know what stuff you've got running on your systems. This is one where I would look at it and I'd have a harder time figuring out what was the cause of the problem. When they came down to this area of the trace down here, you can see there's a whole lot of group policy going on in this place. Lots of love for group policy scripts. Where is it? Here. They came down to this part. Here's gpscript.exe. Here's a script that they're running here. logon.vbs. Here's another command batch file, if member, another wscript, a frame package. And what they saw with this frame package run was taking a very long time. This frame package is from McAfee. And then this is launching as a bunch of other things, including another installer, which is taking a very long time. And that's installing something from McAfee. And there's the cleanup from McAfee. Their question at this point, this was the information they needed to figure out the problem. Why was McAfee being installed every single time the system booted? So they went back to the IT people, said, hey, why is this reinstalling? The server admins went and took a look at their GPOs, and they realized that the McAfee installed GPO was inadvertently applied to these new OS image that they'd rolled out, when it shouldn't have been, which was causing it to get executed every single time. So the GPU should have been removed after this rollout. They removed the GPO. The performance went back to normal. And, of course, the IT guy that caused the problem took the credit for the solution, which is the way it normally works. All right, let's take a look at a different category of problems. But then let's just review that one really quickly. Boot logging. Looking at the boot trace and figuring out what's going on during that boot trace, especially when it comes to GPO processing, solve the problem. In this case, we're talking about error messages. How many people have seen a bogus error message? Okay, just want everybody to raise your hands. It's late in the day. Anybody never seen one? Okay, just checking to make sure nobody's lying. And how many people have seen one in the last 5 hours since this morning? A few people? Okay, you know how to troubleshoot them. Let's take a look at one that I ran into personally. And this is where it's kind of a really cool feeling when I run into a problem and then I'm like, oh, I know, I use a Sysinternals tool, and then I solve the problem myself, and then I send an email to myself thanking myself for saying, Mark, your tools really rock, and yeah. So this case, I was working on a PowerPoint file. And I tried to delete it. You can see it's an exec review for infrastructure as a service, and I'm trying to delete it. It's sitting here on my desktop. And I tried to delete it, and I get this ridiculous error message. Let's reproduce that error message, because I can reproduce it at will. So I've got a full file here. Oh, here's a directory that's just begging to be deleted. Oh, but I can't delete it because another folder or file is open in another program. Well, do I see anything that's got that can't delete folder open? I've got Autoruns, I've got regedit, I've got some here Explorer, I see got Process Explorers, I got IE to some standard pages, I got PowerPoint. I got nothing visible. And that's exactly what I ran into here. I'm like, there's nothing. I even forgot to set up Process Explorer as the default task manager. I ran it, and it told me what had the thing open. It was File in Use had it open, which... So what I did was use Process Explorer's handle search. I searched for the name of that PowerPoint name, and it showed me that there was a PowerPoint running that I didn't see. And here it is, launched as a child of service host. It was some decom automation way of launching PowerPoint, but it didn't have a visible window. It was hiding. And yeah, I don't blame it, because Office and I, we've had a kind of a rough relationship over the last 15 years or so. And sometimes I get pretty pissed off at it. So every now and then it gets really annoyed with me and starts to hide. In this case, it was hiding. But I found it, and I took care of it. And I solved the problem. This case, let's go take a look at this one. And Cant delete. And it's Outlook. Well, Outlook is normally the cause of the problem, but no, I'm just kidding. And I don't have Outlook visible on this desktop because what I did was launch it on a secondary desktop. It's another Sysinternals tool. Unfortunately, this second desktop is having a problem, but you can see Outlook is there. Outlook is having a problem, which is, I guess, par for the course. But Outlook is over there, and the reason why Outlook has that directory open, this is an annoying behavior that I've reported every year for the last 5 years to the Outlook team, which is when you save an attachment to a folder, Outlook keeps a handle open to that folder. Just, hey, you might want to save something else there, so I'll save myself the trouble of opening that thing again. And then you run into this kind of stuff, which is kind of annoying. So there's a one way to deal with this, which is to kill the process in question. Here's Outlook. There's another way to deal with that, and that is to close the handle. If I go and search here, well, actually I can just search for Cant delete. And if I click on this, it takes me right to what's called the handle view. That particular open resource of Outlook, and I can say close handle, and I get a nice warning. The system's already unstable, so I just say yes. And then I get the red, which shows that handle's been closed. And now I can say try again, and then boom. I didn't mean to delete that. No. And then I've taken care of that problem. So that was my own case. Let's take a look at another error message case. And I reproduced this one too. This one somebody sent in to me. And I assumed when they sent it in to me that they were saying, hey, the App Store, Windows 8 App Store, is just babbling at me in Spanish. And actually that's not what the problem they were reporting was. It's saying, and so what I did, I took an immersive class in Spanish so I could read this to you. So let me give it a try. La tienda Windows no está disponible en áreas de trabajo de Windows to Go. So that's the problem, which is, yeah, thank you. Berlitz really paid off. So let's go take a look at this problem, which I've reproduced. Let's go to the App Store. Isn't available on Windows to Go workspaces. This is obviously not a Windows to Go workspace. I'm really running the full desktop Windows. They thought correctly. This gave them a hint. It says it's Windows to Go. Well, why is it Windows to Go? Windows to Go is when you put Windows 8 on a removable disk. And they had installed Windows on a Mac Store SATA disk, but for some reason Windows thought it was a portable USB disk. So what did they do? They captured a process monitor trace. And let's capture a process monitor trace. That's the other process monitor. They captured a process monitor trace. Actually, why don't we load this up, their trace. And case of Windows to go. Reset the filter. And they scanned through the output when they reproduced the problem and came across this, a reg query value from the store app of this registry value, portable operating system, that said 1. And let's do a jump to in my registry. Oh, I'm not running it elevated, sorry. You need to launch regit. To get that jump to and regit it, you need to run elevated. Where'd you go? So let's load that file again. And mistaken to go, log file. It's loading it in. Going to find the key again, jump to it now and regit it. Because we can go right to that, set it to 0, go back to the store, and voila, we're going to connect eventually. There we go. So that's what they did, was solve their Windows to go problem. Now I reported this, of course, to the Windows guys, and they figured it out, that there was a problem when you have disks using certain disk cloning software. It copies the disk ID, and if the disk ID matches the disk ID of the boot system matched the disk ID of an external volume, which they'd previously attached, then Windows would think you were running booted off that external USB. So a hotfix went out for Windows, where if the boot disk ID is always treated as local if it's on non-rule media, and so that fixed the problem for anybody else that might run into it. But this particular person was able to get past it by using Process Monitor, a few minutes of looking through the trace for clues as to what the store might be doing, and solved it. This one is another case where I solved this one myself, which I was very proud of. So when you can set the Windows 8 lock screen to a custom background. But I RDP into my laptop, I take home, I take to work, and I RDP into it from my systems at home and work to go and do stuff on the laptop, and I only take the laptop off. So what I noticed was when I'd log into my laptop locally and then lock, I'd see the nice lock screen that I configured. But when I RDP'd into it, I'd get the stock, Space Needle thing. And not that I don't like the Space Needle thing, but I like my background that I picked. And so I was like, I want to fix my background, so how do I do that? And what I'm going to show you are the two traces I captured. One of what Windows does, how it finds the lock screen background for when you'd lock it interactively versus when you RDP in and it locks the screen. So there's two traces here. Lock screen right, which is the one where it worked fine, and lock screen wrong, which is the one that I RDP'd into. And I dragged these side by side, and the first thing I did is I knew that it was a JPEG file for both of these. So I said path contains JPG, and then I said path contains JPG on the other side. And the side on the right is much shorter, but you can see that it is querying the lock screen from this location down here, from lock screen inside of my user profile, S-1- whatever. That's my SID that maps to my user account name here. On the right side, at the very end of the trace, the last lines are logon UI querying the lock screen from this location, from this profile, S-1-15, which is the system profile. So what it's doing is saying, I'm not going to use yours, I'm going to use the system set lock screen background. How do I fix that? Well, I did a jump to that location, and it turns out that that location is not accessible to normal people. Not even admins can access that directory. So here's that directory, access denied. So what I did was run another tool, psexec which is a Sysinternals tool to launch processes remotely generally, but with the S switch you can launch it locally, and you can get into parts of the system that are only the system has access to. And here are the system-defined lock screens. And what I did at this point was copy the one for the right resolution over on top of the one that's there in the system after I messed with the ACLs to let me do that. And now I was good. So I was sitting around the dinner table telling the story to my wife and daughter, and they said, and my wife said, "Why did you do that?" And I said, "Well, I wanted, my custom lock screen. It was really important to me." And she said, "No, I mean, why didn't you just do it using this group policy setting?" Yeah, and then I felt really embarrassed in front of my daughter, so. Okay, let's take a quick look at application crashes. This one came into Microsoft support. Every time the user went to look at their favorites, they would get this crash. Kind of like this. That wasn't supposed to happen. No, I'm just kidding. So what they did, this particular support engineer is probably one of Microsoft's finest support engineers, and his name is Andrew Richards, and he gave a class this morning called Hardcore Debugging. He's like the master of really deep Windows debugging. So he got on the case, and he said, I'm going to figure out what's going on there from the crash dump of that process. How do you get a crash dump of a process? There's a few different ways, but one of the ways is using a tool I wrote called procdump that Andrew's actually contributed a bunch of features to. So Andrew really likes procdump, and what we can do is, here if I just close this and I go to Process Explorer, I can, actually let me launch a new version of Internet Explorer. And here's the one that's going to crash is 8868, and what he did was said procdump 8868-E, which says take a dump when this thing, sorry, I have to laugh every time I say that, which is to generate a crash dump every time this process faults. And now when we go do this, we're going to get a nice dump file coming out of it, which goes to right here, and we can load that into Windows, the Windows Debugger. Windows Debugger, you want to point it at symbols just the same way. Where did I put that? In temp? Yeah. Okay, in temp. You're going to want to point it at symbols the same way that I showed you, but then you're also going to want to look at the stack trace. What was this thing doing when it crashed? It was doing some kind of merge sort, compare. Well, what's favorites doing? Well, favorites is organizing a list of your favorites. So at this point, what he thought was, let me find the PowerPoint again. I've lost it in this list. Here it is. Oh, no, that's not it. What he did was he deleted something that had a bullet in it. He thought maybe that was it. There's 2 bullets. Maybe that was it. He moved all the favorites to another folder. It still crashed. What he then did was capture a process monitor trace, set a filter for action is success and path contains favorite, and then when he looked at the trace, he saw that the problem was, or that might be, that this particular registry value here with a bunch of binary data in it called order could have been the problem. And he did a reg jump too. I've got this hooked up here. What he did was rename this. And you can see I've got a back of it. And then tried it again. And there we go. And the problem was fixed. So it was somehow a corrupt registry value that he fixed for that person. So just a few minutes using 2 different tools. In this case, he used Process Monitor, but he also used procdump, which is a tool that will also capture process dumps if you've got sluggish performance, high CPU utilization. you can say procdump minus C and say capture a dump of a particular process and even launch the process minus X CPU stress procdump. I've forgotten my own syntax. Procdump. That's what happens when you see the xdump file, image file, arguments. Okay, I can't remember how to launch a process. Oh, so you know what I'll do? I'll say dash C25. I'll launch CPU stress. Oh, here we go. Which is a little process that will just consume CPU usage. And if I say generate a dump when it's consumed 25% of a CPU stress, what it'll do is after a certain number, by default, a certain number of seconds of CPU utilization, it'll start counting. And it'll say when it gets to, by default, 10 seconds of above that threshold, it'll generate a dump. And that's the way that you can, another way that you can capture spiky behavior. This is what Exchange support engineers, for example, use when they've got an Exchange server that's spiking every now and then. They'll run procdump and say, capture a dump when it gets above a certain amount, and then they can go take a look at what's causing that behavior. It even supports reflected process dumps, which is the -R switch, which doesn't actually terminate the process. It creates a clone process, generates a dump with a clone while the first one continues on, which is really what you want to do when you've got an Exchange server serving customers or a domain controller, lsas.exe, is not interfere with the mainline execution. Let's turn our attention now to blue screens. How many people have ever seen a Windows blue screen personally? Okay, but you know, Windows has gotten way, way better. And in Windows 8, we've virtually eliminated blue screens. How many people have seen a Windows 8 blue screen? Oh. Okay, but it is way better, because, right? How many people have never seen a Windows 8 blue screen? Because you're not running Windows 8? Oh. How many people have seen a blue screen in the wild? Few of you? I'm a collector of blue screens in the wild. Some of you that have come to previous ones might have seen some of these, but they're just too good not to share. And I've got some new ones in here too. And so let's go take a look. Oh, by the way, I forgot to show you this crashing. This one. Where is it? Crash, crash, crash. Oh, yeah, this one somebody just sent to me, a Microsoft person traveling back today. At the Southwest Airlines counter, from Orlando to Vegas, the ddc.exe crashed on the Southwest. It is right behind the ticket counter. And this Microsoft person's there and notices it and said, oh, it looks like you got a problem on the screen there. And the lady turned around, I'm not making this up, she said, who's Dr. Watson? But I've got some really good BSODs here that I've been collecting. So this is at SeaTac, and this explains why the luggage never shows up there. This one, just a classic. This is the metro system in New York City. This is about a year ago, so I think they've upgraded since then. But this is running NT4. This is where you buy your tickets for the subway. And then there's a picture of it blue screening. So is anybody running NT4? Anybody in here running NT4 still? Yeah? Is your system on the internet? I hope not. Because I got a lot of free tickets out of these systems. So here's one from a billboard. CompUSA's bestseller. This is an oldie but goodie. Anybody remember CompUSA? Yeah. This is why they went out of business. Here's a concert. Actually, this one is intentional. There's apparently, this is like some trance guy. I don't know. Is anybody familiar with this guy? But he's like a techno trance guy, and he thinks it's cool to have blue screens as part of his show. So this is not a real blue screen. This is probably the blue screen of death screensaver, which is something I wrote, which you can use too. This is Dave Solomon at the airport. There's a few I've got of Dave Solomon at the airport. This is the most recent one of Dave Solomon at the airport. And every time he runs into one of these, he gathers the people around him that are walking by and he says, hey, come over here. Let me tell you why this thing has crashed. Flight information. Airports are just, that's a gold mine for blue screens. Here's a floor. It's one of those overhead projection floors. I guess then, normally they're like got those balls that you can kind of pseudo kick around on the floor. Here's a gas pump. This is one of my favorites. It's a gas pump, and I think, based on this next picture, I know why it blue screened. The really funny thing about this is that this is not related, but somebody a few years ago sent me, this is a picture of a car sitting in the building 26, which is the center of the Windows Core team building, of some developer that had driven into work with the hose sticking out of the car. I think they worked on Task Manager. Here's a mall. Here's a conference room at Microsoft. We even, so we're running our own thing there, but we get it upside down there. Surface. This one's also another oldie but goodie. This is the most public blue screen ever. So I've got some most of blue screens here. This one's the most public. Anybody recognize this? Yeah, it's the Beijing Olympics. Anybody notice it when it happened? Because this was on TV beamed whatever. Yeah, you did? And there it is right up here. So if you're really vigilant, you could see blue screen in front of the whole world there. Speaking of Olympics, this is at Olympic Park in London right before the Olympics last year. Blue screen on the way in to greet people to the Olympics. Paddington Station, London blue screens theme here. Would you like a blue screen to go with that, Panini? This is the Moscow airport. That's why I don't fly through Moscow. It's a Walmart MasterCard machine. This is another just an oldie classic. Anybody remember this guy? There are no tanks here. No tanks in Baghdad. Anyway, so, and I've got one. Has anybody heard the blue screen from space? Anybody? All right, I guess I can play that for you too. Wait, let me turn this up and start over.
Go ahead, Al. Alpha Space Ground 2. Go ahead, Al. I was looking at ExpressRack 1's laptop to do your message 903, and what we have right now is a blue screen with white writing on it. Looks kind of like DOS sort of information. The last thing is beginning dump of physical memory, and it says to contact your system administrator.
That is interesting. Stand by. That is interesting. Alpha, hunt still, Spacegram 2 for ExpressRack 1.
Go ahead.
Yes, Susan. Jim called down about the message that was on the ExpressRack 1 laptop. And I'd like to get the exact words of that message.
Yeah. All 15 lines of hex.
Okay, stand by. Go ahead.
Yes, I was just going to continue on and say that after you give me those words, I would like Jim to go ahead and reboot the laptop, start the Express application again, and then continue on with OCA message 903.
Yep. Most popular troubleshooting technique for blue screens right there. So let's talk about blue screens. Blue screens happen when something goes terribly wrong in kernel mode. Something's gone fritz, and what Windows' job is to protect your data. So the first thing, by the way, how many people have, I already asked you. Anybody seen a blue screen in the last day? Well, a few people. All right, so I'd be curious. Send me those dumps, and I'll analyze them for you. But the reason that Windows crashes is to protect your data. Something's gone wrong in kernel mode, the most sensitive part of the operating system, the most privileged, and it could be wiping out your PowerPoint, your database. By the time Windows has detected what's going on, its job is to protect your data and shut down everything as quickly as possible. And that is what it calls this function, blue screen of death. It's actually called bug check inside the system, which is shut down the CPUs, save a dump if configured, and then by now, today it's reboot by default. There's online crash analysis, so we get the telemetry at Microsoft, we analyze the dumps, and when we find problems, we contact the vendors or contact the product teams, fix the problems and release fixes on Microsoft on Windows Update so that you get them if you are hit by one of these things or get told that there's an updated driver from a third party, for example. But in many cases, you just have to solve on your own because there is no recourse. You can't wait around for your servers to get healthy for Microsoft's support people to go figure out what the blue screen is, talk to the vendor, and get you a fix. You need to move on with your business right away. This particular case came into Microsoft support. A user complained to the IT that Windows 8 would crash when running IE. So it's not possible for a user mode process to crash the system. It has to be something in kernel mode. So something was funny going on. IE was tickling something in kernel mode. They opened the crash dump file, and I've got it right here. And it's in demo case of IE BSOD. And what you'll want to do when you run into a situation like this is load it up in the kernel debugger. There's a nice hyperlink right there. Press it. This is going to take a second while it looks for some symbols on the network that it's not going to find. We've already gotten a hint for what caused this, just by the fact that it couldn't find symbols for this thing, aswnet.sys, because it's going to find symbols for all of the Microsoft components that are in the stack and related to the point of the crash. This is taking a while to come out. But what we're going to see is that when the stack trace shows up, this driver is sitting there right on the stack at the time of the crash. And this user used that information to go look and do a web search for the Avast antivirus engine with Windows 8 as another key search word and came across this, which says we've just released a program update that includes fixes for Windows 8 BSOD. Now this is a comforting statement here, but still investigating some issues. So yeah, I'm sure they got that fixed. So they applied that update to Avast, and the problem was solved. Let's go see if they're still having trouble getting to the network. But what we've already gotten the information that we had. It'll say probably caused by this driver. So that brings me to the conclusion of the talk. I've got about 2 minutes to summarize, and then if you spend another few minutes, I'm going to show you something as an added bonus here. But what I hope that I've shared with you today are some tools, some techniques, the Sysinternals tools primarily, and Windows Debugger, some techniques that can help you solve problems that you might not have ever been able to solve in any other way. And sometimes I solve these problems, I'm like, what do normal people do when they run into these kinds of problems? Because it's literally, without looking under the hood, there'd just be no way in hell to fix these things. And so you'd be really running with systems that are screwed up for a long time. Re-emphasize this. There are other resources, the Sysinternals book, the blog, the webcasts, as well as Windows Internals. And if you solve one, please send me the case so I can add it. And I'm going to go ahead and close it, the official part of the talk, and if you want to go, you can go. I want to thank you very much for attending the talk, and I hope you have a great remainder of TechEd. And then if you want to see something interesting, then wait, or you might as well just, all right. Okay, here's the bonus programming. How many people have seen this? Let's see, raise your hands again. So this is our way of saying, hey, you know what? We feel for you. It's really, it's really cute. You know, take your mind off the blue screen. Oh, that's such a cute little sad face there. And so what if I've lost my SQL database and the execs are mad at me? But, and I want to share with you the reimagined one, because we found this wasn't connecting enough with customers, especially the younger audience. Really kind of was like, hey, that's just lame, just the simple sad face. I mean, what, are you trying to be cool? So we've updated it with blue, for blue, to say this. Okay, but that's not what I want to share with you. What I want to share with you is I'm going to change the color of the Windows 8 blue screen to the color that you tell me you want. How am I going to do that? Well, first I'm going to shut down everything so that I don't lose any data. And what color do you want me to make the blue screen? Green? Pink? Pink? Is Chris Jackson in the room? Too many pinks in here. Blue? That's creative. Red, orange. I hear red, orange, pink. You know, a solid color was actually going to be easier for me. All right, here, let me, I need to get one little hint. No, not that. Case of, oh, I'm in the wrong folder, no wonder. All right, so BSD. There's a function, so what I did is dug through where KE bug check calls into, and it calls into this function bgpfw display bug screen. I booted the system in debugging mode so I can do local live kernel debugging on it. And let me set the font a little bit bigger so you can see what's going on. View, font, 14. Oh, no font. That name. And I'm going to do a U. Disassemble of that function, and what we'll see in here is it's going to call set clear screen here. So I found this. This is where it clears the background screen and it passes the color. Register calling conventions are past the color, past the first parameter in the ECX register. Everybody knows that, of course. And where is the ECX register coming from? It's referencing this variable, RDX, this register, which is right here, which is coming from RCX, which is coming from here, which is coming from this address. So we've got to find the color. Unfortunately, it's not DQ that plus POI of this plus 18, and then this plus 24. And let me make sure that's what it is. Nope, that's it's that POI. Nope, that's not it. What am I doing wrong? Hold, bear with, 28. 28. You know, there it is. This is the color right here. It's in RGB, reverse RGB, so if I do a dump bytes, it's going to be blue, green, blue, green, red. So that's the blue screen color that is printing. So if I do EB to edit that, now what did we want to say? Red? How about red? Red? Okay, so first one is blue, so let's set that to 0. Second one is green, so let's set that to 0. And third one is red, so let's set that to FF. Say, let's make sure it's stuck. And there it did. Yep, there it is right. Wait. That's not what I said, is it? Did I boot in debugging mode? No, I didn't. Blue. Well, oh, I know what I'm doing wrong. I think. Or, you know what? I'm running out of time. And unfortunately, this demo is not working the way that I intended it to. Oh, wait, did I set it? All right. Sorry about this. Let's just take one more look. Oh, now I've set it to black. Okay. You want to see a black one? Sure. All right. Let's set it to black. And what I'm going to do is run a program called Not My Fault to generate a crash. It's called Not My Fault demo case of Not My Fault. And let's see if it works. And, oh, it's red. Oh. Now it makes sense. That FF was the red color, so it worked out. Anyway, I hope you had a great time here. There's a Sysinternals session. If you want books signed, come up here. Have a great trip home. Hope to see you next TechEd. Thanks.